Yesterday we discussed another design, but still a Latin square, but in each and every cell you will find more than one values. So which means that but you still test for rows, columns, and treatments. But in each and every cell, you have replications. So remember yesterday, without the waste of time. Oh, sorry. I'm not sharing anything, right? I'm supposed to share the whiteboard. This what do you call this? I want to share the screen. Let me know if you're able to see the screen. Are you able to see the screen?
Yes.
Oh, thank you very much. Again, yesterday the attendance was not that good. I know I will be wasting time if I ask why you decided not to attend yesterday. I'll be just wasting my time by asking for some explanation because I know you're going to come up with something.
No,
So let us.
That's why they don't
This is our last test. Yesterday.
There's a strike outside. That's why they are not here because they did not.
Mr. Manyama, yesterday or today? I'm talking about yesterday, Mr. Manyama.
What you are referring to?
Oh, today is better. Yesterday we were only 51, Mr. Manyam. Yesterday we were only 51. So there's a strike.
Yeah, there's a strike of campus allowance.
Mr. Manyam.
Yes, there is a strike of campus allowance.
Okay. So for those who missed our class yesterday, we introduced another layout of Latin, but now we in each and every cell we have what? Replication of some values there. So you see, you have 40 and 50 in one cell, which goes with C. The second cell there is 40 and 40, which goes with B. But with the Latin square, you don't test for interaction. So even if the values are like this, you continue testing for what? Treatments, rows, and blocks. So I explained this model that whenever you solve a question, when you are practicing in your rooms, the first thing that you have to do, learn how to write the model of each and every design that you are solving. Don't solve a design without writing its model. Write the model, define the parameters based on the model. I explained this yesterday, what I mean by that. Because when we were writing a first test, I was surprised that almost 80% of the students who managed to write that test, they failed to write the model. And the marks for the model, I thought this just free marks. You're just giving you marks. So I was surprised while students, they failed to write the model. So it's very, very important, leaders, whenever I give you a question, maybe when we are doing tutorials, even if I didn't ask that question, write the model. write the mod practice, so that if we are asked this type of questions in a test or in an exam, you won't fail to write mod, because it will be something that you have been doing for some time. So, not a waste of time. We calculated this yesterday, leaders. I asked you to go and complete it. You said your SS treatment went by this. So when you publish what are getting, leaders? Can you please give me the answer for SST?
$2008.333.
SST, what get?
2008. It's 008 triple
Point
three,
33.
three.
Yes, 0.33. 008.
Yes, sir.
And then again, I asked you to find SS column, SS row, SS total. So now, let's construct the ANOVA table. So this one is just, I introduced it yesterday before we knock off, but we're still coming to this one now. The Gray-Collatin square design. So allow me now to remove this part here. Mr. Manyam. Mr. Manyam.
Yes, sir.
Why is the strike now?
The
Why
strike
now?
is
Why is the strike now?
the strike is because the student did not receive the allowances, off-campus allowances, since the SRC, the previous SRC,
And they
was
were
in
expecting
charge.
it when?
They were expecting it
Oh,
actually in the first of this September. Then something
month.
delays up until now. It's been 9 months
Oh,
now without money. Students are
oh no.
suffering.
I get it. Let's continue. Thank you for the information. So now let's contract the ANOVA source treatment rows. So for writing, not a must that you must always start with the treatment or the rows. You can start with any. There's no order that strictly must start with the columns. You can start with the rows, columns, and the treatment. It's fine, as long as the values are in line with errors. And total. The degrees of freedom is still the same as for the normal where you don't have the replication. The degrees of freedom of treatment based on our question is t minus 1, which is 2. For the rows is 2. For the columns is 2. For the total, how many values are we having there? So it was 18, right? 3 squared by 2. So this will be 17. 17 minus 6 is 11. Sum of squares. Yes, the guy who was giving me the values, please help me again. You said this one is 2008.33. Let's get the second one.
108.
Let's get the second one.
108.33.
108.33. Column.
108.33.
Oh, that is why memory was asking, is it possible to get the error substitution method or the total? It's fine. Help me, guys. I'm waiting.
Total is 5462.5.
5462.5, like this.
Yes. Then the error is
The error, my brother, before it disappears.
3237.501.
And then MS.
Is
Help me, my brother. Don't mute your mic. Just let's continue.
Yeah, it's 1004.167.
Yes.
Then the other one is 54.167.
Even this one, right?
Yes. Then
And
MS
then the MS
is 294.318.
Yes. Wait, my brother. Let
Say.
let's wait for the guy.
Should I continue?
Say.
Let me get this information from my brother. I will get back to you now. My brother, are you saying 294.318?
Yes.
Okay. My sister, what are you saying?
Say, Khanti DF4 total is not T squared minus 1.
It's T squared minus 1. We have 18 values. Are we not having 18 values?
We have 3 treatments, Mus.
T squared R.
Oh, you.
T squared R minus 1 is.
Okay, thank you, sir.
I will find it. Remember, my sister, we're dealing with what? We're dealing with a replication of Latin square. How many values do we have there if you count? Because remember, T squared minus 1 is T squared must be equal to n. T squared, it must be equal to n. So if you say T squared here, are we getting the number of values that we have here? No, right? But if you say T squared multiplied by R, you get n. So it's T squared multiplied by R is equal to n. That is why leadership is saying 17.
Okay, thank you, sir. I missed the R.
It's fine. Let's go to leadership. Continue.
Yeah. F for treatment is 3.412.
3.4. Then for this one
is 0.184.
help him, guys. Help him. Oh, it's the same thing, right?
Yes, it's the same thing.
Because the values are the same there. So the tabulated value. The tabulated value. What is the tabulated value?
The tabulated value is 3.982.
F of 2 and 11 is what, my brother?
3.982.
So if you can check, guys, there's something that one of the students said yesterday when he was consulting concerning the hypothesis. For now, guys, from the part that you covered with Mestelvo, chapter 3 onwards, there is no need for you to write H0 and H1, because the reason why we're emphasizing that you should write H0, H1, that mu1 equal to mu2, wanted you to know what to get to know what we're testing. But now we assume that you understand when we say I say testing for the treatment, testing for the blocks. So there is no need a quicker method of testing. You see now you have to test for three things there. You have to test for the rows, columns, and the treatment. So the best way of doing this is, here's an example, guys. Let's do this one together. Yes, I'm listening.
Sir, can you
Yes.
please
Yes.
explain the
Yes.
part of hypothesis testing?
Explain how.
You were saying there's no need to do H1 and H0, so I don't
To
understand.
write them that but in a mathematical form. There is no need. So I want to show you how to do that. Now you have constructed your ANOVA, isn't it, my brother? You have constructed your ANOVA now. Here it is. So now you want to test, isn't it? So you can simply say, because I assume now you know what you are testing. You can say testing for treatment. Treatment. You see it, my brother? What is your decision? When testing for the treatment, are you rejecting or failing to reject? You fail to reject A0, isn't it?
Yeah.
Fail to reject A0 and conclude that the treatment means they don't differ, isn't it? Are the same, isn't it? And conclude that the treatment means are the same. Or they don't differ, or you can get the statement from any book is fine. Now, because you have tested that, you see, I didn't write H0, H1, but I know what I'm testing, isn't it? Because I managed to conclude the right way. Now, you say testing for blocks, or in this case, we have to be careful, we have to be specific. Rows. What is your decision here? Fail to reject A0 and conclude that blocking by rows, or be specific there, where row is age, was not effective. Yes, you do the same with the columns. I'm listening, the leader. I think there's a hand. I cannot see whose hand is up. Ne? So please, if you want to say something, the floor is yours. Testing for the columns, you do the same thing. Don't write H0, H1. It will consume your time, unless if it's an assignment. But for the test, because you have limited time, don't write them. The H0 and H1. Just indicate the decision and your conclusion. I thought the end.
Yeah.
There is a end or what?
Say, you are saying, oh, from the ANOVA, I
Someone
can
is
just
talking in
conclude.
it.
Say, can you hear me?
Yes. Yes.
You are saying from the ANOVA I can just conclude, right? There's no need for me to write the null and the alternative.
True. From chapter 3, onwards, don't write those things. Even the part that you're taught by Mr. Lebo, don't write the H0 and H1. Just indicate the way I'm indicating here. If you're testing for the interaction, just say testing for the interaction, show us your decision and your conclusion.
Okay, thank you.
Thank you very much. So you'll do the same with what? You will do the same with what? You do the same with the column, how you conclude. So now, let's talk about the pairwise comparisons now. The formula for the pairwise comparison, how will they look like? Formulas for pairwise comparison. Are we together, guys? Can I? I'm not sure if, since you're quiet, if you can hear me or what.
Yeah, we can hear you,
Let me
sir.
write them here.
Yeah, you can move, sir.
Now we move to pairwise comparison. What I can emphasize, guys, the only thing that is changing is the standard error. For all this thing, is the standard error that will be changing. So if it's LSD, LSD will be given by T alpha over 2 degrees of error MSE over TR. Duncan and student Newman Kells will be given by the standard error, which is step 2. The other steps remains the same. The part that will be affected is this one. The standard error for the treatment will be given by the square root of MSE over TR. Oh, same applies to take, right? Even take here, even T alpha. The only difference is there. So if you're having a replicated Latin square design, don't forget to divide by what? TR. If it's the normal Latin square design, we divide by T. And again, the student who they love these two too much. This one. These two. Oh, let me use a different color. Student love these two much. If with Duncan or Teki, they want to put a 2 here. If you have checked very well, guys, the only pairwise which is having a 2 is only Duncan. It's only LSD. The other ones, they don't have 2 MSE. So be careful with that one. So that short note. So if you have this information, you cannot fail to find the pairwise the confidence intervals for these designs. So suppose, remember, based on our findings here, there is no need to perform pairwise comparison. Can you see it? Because we failed to reject for the treatment. But let's say, regardless of what our findings here, let's do it. Regardless that we have failed to reject the null hypothesis, let's do pairwise comparison for practice. Yes, I think like there's an end. Which one do you prefer? Which one do you prefer from the three, from the four?
SNK.
Danke. So suppose so already my sister, there's someone who said Duncan. So let's use Duncan because the procedure is the same. You order your means, right? Give me your means in order, or it's fine. Order your means. Give me in the form of letters, the means in order, or give me the totals for each mean or for each treatment,
A,
so that will help others.
C, B and C, man.
A is what?
A is 190.
Are those the means?
The total.
Is the mean?
He said the total.
Or the total? Okay. B. Thank you. B, Mrs. Manga.
I said A, B, and C.
B is
Now
267.
only 190. And C.
345.
Guys, give me the means now in alphabetical. You're saying these are the totals. Give me the means now. The minimum mean will be what? I think it will be mean A. So the order remains the same, right?
Yeah.
What is your mean? And how did you calculate it?
The first mean is 63.3.
How did you get it, my brother? You divided by what?
3.
Why 3?
Because we have
So
Why
are we
3, my
dividing by
brother?
3
What's the
or 6?
definition? What's the definition
Isn't
of
it
the mean?
6?
It's 31.6.
What is the definition of the mean? 31.6. The second one?
So we divide like
Guys, why are you taking time?
40,
33.3.
43.33.
The second one?
43.33.
The second one, right?
Yes.
The last one?
Fif-
The last one?
57.5. 57.5.
Give me the standard error. What is not error from the ANOVA? 294.318. Two 94 point something there divided by 3 treatment multiplied by 2. What are you having there? So the other processes, the other
7.
steps are the same, guys. The other steps are the same. 7 point something, right?
Yes. 7.003.
So from there you'll combine step 3 and step 4, right? Now you find your R2 and R3. Already now it's saying 733 I'm told 7.33. Can someone go to the Duncan's table and get two values which are in line with degrees of freedom of error, which is 11? Which are in line with degrees of freedom of error, which is...
Yeah,
Can you
sir.
please go to the Duncan's table
The first value is
and get the two
3.113.
values?
Sir.
3.113.
Then the second one is 3.256.
I think that one is the first one. The second one,
3.256.
2.5. When you apply a mathematics, yes, your final answer for R2. Guys, are you fine?
It's 22.81. 22.81, the first one.
20.
22.818.
22.81. The second, which one is that one? So are you saying that
23.866.
is it my network? 23.866. So let's find the differences now. Let's apply the largest.
Sir.
The smallest. That rule. Remember the rule?
Sir, the standard error is wrong.
Yes.
Yeah.
I think
Sir.
Yeah, that's what I was given, right?
Yeah, but it's
No.
wrong.
No, so we said 7.003.
Give me the...
It's 7.003.
Yeah, give me the right thing.
Yes, it's 7.003.
Your network is bad, sir.
I reckon it's like a damn man is fit for life.
Would you mind?
Eh, Mike. Eh.
I think I don't know what is the problem here. So it's fine, guys. Since you know the procedure, you will continue. I said it yesterday that if I ask you to give me information, is that the information
Sir,
wrong? You don't
sir,
wait until we're done and then you say the value is wrong.
sir, your network is bad.
I'm listening.
We can't hear you nicely. Your network is bad.
I can hear you.
I'm saying you are cutting, sir. We can't hear you properly.
Chris,
Sir, are you talking?
no, I'm trying to reconnect if you can hear me.
Oh, okay, sir.
We can hear you now.
If you can hear me, I'm trying to reconnect. Let's break. Oh, you can hear me now.
Yeah.
Please, you know the procedure,
Sir,
right? Because
sir,
now the issue is the values.
sir,
Yes, Mang.
T squared
Yeah.
R minus 1 is not the degrees of freedom for the total. T squared times R minus 1 is not the degrees of freedom for the total, because for the error I think it's 9. Or maybe you can explain.
R.
Sir,
Hello. What about now, Mr. Smanga?
You're
Can you
fine.
hear me now? Okay. I was trying to change the network. It seems like where I am, Vodacom is giving me problem. So we're trying to connect using a different another network. So what I was saying is that you know the procedure, right? So the procedure is not an issue, Shokan. Now, because it seems like now we're debating about the values now, and the values I'm getting them from you guys. So if you don't correct me, the wrong value. So let's go together, guys. If you notice that, let me know. Don't wait for me to write up to the end and then you say something is wrong. So what is your R2? Shokani? Or Smanga? Anyone who can help us. What is your R2?
R2.
Yeah, it's 21.800.
Shokan, I cannot hear you. You are breaking.
21. Say.
I'm listening.
800.
It's fine. The second one?
22.802.
Like this.
H802.
Can we move with those values?
Yeah.
Now let's do the pairwise comparison. Let's do the pairwise comparison. I think those means are in order like that. C minus A.
25,
B minus A. What is it?
Sir.
Yes.
The degrees of freedom for the air, I'm saying, is not 11, it's 9, because it's given by r minus 1 multiplied by t squared.
No.
And
No. You're wrong, Smanga.
Go to the guide, page 45.
Yeah, I know that formula. It's wrong.
So for the total, what is for the total then?
Smanga. Degrees of freedom for the area we were given there on the study guide.
It's fine. Let me do it like this. From the study guide, what is the degrees of freedom of total?
It will be 12, sir.
How can it be 12?
Is t
total
squared.
12.
T squared r minus 1.
Is this one right? So 18
is 11.
18. This 18, right? Minus 1 is 17, isn't it?
Yes.
So
Yes.
because to get the degrees of freedom of error is substitution method, isn't it? Is total minus treatment minus row minus column. The way how it means even this one can be correct. This one. Oh, sorry. Now it's as if I'm canceling everything. So let's do like this. It's fine. Let's apply maths. T squared r minus 1 minus t minus 1 plus t minus 1 t squared r minus 1. What is this? This 3t, right? T squared minus r. Oh, t squared r, sorry, minus 3t plus 2. What is on the study guide, Mr. Banyama, Mr. Smanga? Was I'm getting t squared r minus 3t.
So on the study guide, they are saying by replacing the
Wait,
Latin
Mr. Smanga, I'm saying what is on the study guide? What is written on the study guide?
Sir,
Read what is written.
in the study
Read what
guide.
is written on the study guide. Yes.
Yeah, I'm reading it, I gotta say.
From the study guide, right?
I have r minus 1 into t squared.
R
minus 1.
is it from the
All
ANOVA table?
multiplied by t squared.
Is it from the ANOVA table?
Yes, it is for
No,
Latin.
it's not.
Mr. Smang, I'm saying, is that formula from the ANOVA table itself?
Yes, it works for Latin for ANOVA tables.
No.
Shogani, can you please tell me what is indicated from the ANOVA table of replication of Latin?
Sir, on the ANOVA table for SSE, we were given the degrees of freedom of t squared times r minus 3t plus 2, which
This is what
is
we're
giving
using,
us,
isn't it?
yes.
It's what I just solved now, isn't it? Because for you to find the degrees of freedom of error, this is what you do. This part is the degrees of freedom of total, isn't it? Minus the degrees of freedom of row, minus the degrees of freedom of column, minus the degrees of freedom of treatment, isn't it? Which will give you what? Which will give you this thing here. We just solved it right now, isn't it? So the degrees of freedom of error is t squared r minus 3t plus 2. I'm not sure if I'm still connected.
Yes, you are, sir.
Yeah, we can hear
Yes.
you, sir.
Yes. So this is the degrees of freedom of the replication of Latin. So it's given by that. So I don't know the one. I will check the one that Mr. Smanga is talking about, but it won't correlate with what is happening here. Because if you say r minus 1, so Mr. Smanga,
Sir,
if you say r minus 1 multiplied by t squared, you want to find r. Sorry, my network is troubling me here. Even though I changed the network, but even the one that I'm using, it seems like it's creating some problems. Mrs. Manga, allow me to finish the section and then we'll deliberate on that one, please.
Okay,
Because
sir. I
deliberate
think
on.
I'm a little bit fine. I'll come to consult to you, Barry.
Okay, it's fine. It's fine. Thank you, Mrs. Manga, for understanding. So you can do the comparison, right? And then you conclude. So now we have to, because I want to give you the scope for the test. So I must, because the test is ready, right? The test is ready, it's printed. So we have to make sure that we cover all the things that can be in the test. Well, the test is ready, guys. So we really need the remaining time to cover everything. So please let's work together. Even if I'm disconnected, don't leave the session. Wait for me to come back. So the next one that we'll be dealing with is Graeco Latin Square design. The good thing about Latin Square it's not difficult to do some calculations. These designs are straightforward. Like now, the one that I'm about to introduce, it's the same. It's similar to what the normal Latin Square. It's just you'll be having 4 blocking factors. Can you allow me to deal with these sections, and then if there are any questions, I will attend them towards the end. Let allow me to finish the remaining section, please. If Greco Latin square design or Latin square, sorry. So when I started with this section, I said, what is the difference between Latin square design and standard Latin square design, right? You said that for standard Latin square design, it's a must that the first row and the first column should be the treatment should be arranged in what? In alphabetical order. That is the difference between the two. If you say it's a standard one, strictly the first it should be arranged in what? In alphabetical order. That one is a must. So now, what is the difference between a normal Latin square design and Greco Latin square design? A normal Latin square design will have 2 blocking factors. A Latin square design, if it's not specified that this is Greco or what, it will have 2 blocking factors. But Greco Latin square design is going to have what? 3 blocking factors. I indicated yesterday what are these 3 blocking factors? Still rows, column, and Greek letters. And then alphabets will represent the treatments in it. Represent the treatment. So that is the only difference. So if you can check now, it means we are going to test for what? For the rows, we test for the columns, we test for the Greek letters. And I indicated yesterday that the Greco Latin square design only exists when t is greater than 3. You remember yesterday, guys? Before we knock off, we're talking about this one. You remember it from yesterday?
Yes.
Why is it only existing when t is greater than 3? By
Because
2.
it's hard.
Yes, I'm listening.
Because then the same letters will be assigned to same Greek letters if it's less than 3.
Thank you. Thank you. If it's 3 or less, right? So you must know the reason why the Greco Latin square design only exists when t is greater than 3. It's very, very important to know the reason why it only exists when t is greater than 3.
Sir, can
So
you
the
please
ANOVA
repeat
table
the reason?
is from leadership. Ask the leadership to repeat, not
Can
from
you
me.
It's
please repeat?
because same letters will be assigned to the same Greek letters. Or same Greek letters will be assigned to the same letters. Something like that, yeah. It would be hard to construct it if it's less than
It will
3.
be, you can simply say it will be difficult to assign the third block. It will be difficult to assign the same block because same letters will go with the same Greek letter. Like what happened yesterday. This is what happened, my brother. Suppose your Greek letters, Christopher, is alpha, beta, and gamma. Assign them here. But please, if you put alpha here, you're not supposed to put alpha. Alpha is not supposed to go with A again. Do you get it, Christopher? If alpha
Yes.
already is with A, alpha is not supposed to go with A, even if it's from not on the same column or row, but it's not supposed to go with A because alpha already is with what? With A. So here it is. I can start for you. Where can we put the now let's complete the table. What can I attach for with to B? What can I attach to B?
Beta.
Beta. It can't be beta because beta is already discussed attached to B here.
Alpha.
Gamma.
Alpha is here.
Rho. Yeah, it's a
Gamma.
Gamma. It's fine. Let's go. If we say gamma, it means the last one, the one which is left with, is beta, isn't it? So let's continue.
Alpha.
And where should I put alpha?
Phi.
Where?
Phi in the middle.
Say alpha. Alpha more B.
Yeah.
Alpha.
Sir, gamma on A. B.
Beta on A.
So let's see. Alpha, beta. Let me do like this. This manga is related to what we're doing right now. So you see, this one it's working, right? It seems like for this one it's working, but it's not encouraged for you to have a 3x3 Latin square design. Sorry, Greco Latin square design. One of the reasons is what we said, but even like the way you assigned them, it seems like it's working, but it's not advisable for you to get a 3x3 Latin square or Greco Latin square design. That is one of the conditions. I will share the notes with you now. So one of the reasons that was said is exactly what I indicated yesterday. That I want to check it again. B, beta. Oh, sorry. B. Oh, this is supposed to be B. Where's the other one? Alpha. Where's the third one? It's gamma. C. Are you still there?
Yes.
Where is that one? B.
Sir,
Yes.
why is it like the thing is contradicting with your statement?
Yes. Yes, it's contradictory. That's what I'm saying. It's like saying it goes back to, is it advisable to have a 2x2 Latin square design?
Okay.
Let's go to Latin square. Is it advisable to have a 2x2 Latin square design? No. It's not advisable. So same applies to this one. Greco Latin square design, one of the reasons is that for you to get, remember here we're trying to improve the designs, isn't it? We're trying to improve the design by bringing in the third block. It means we should also increase the number of treatments. We have to increase the number of treatments. When you increase the number of, when you increase the block, even the number of treatments you have to do what? Has to increase. But again, there is theory here which goes with what? Which goes with what we're discussing. So maybe another method is to do what? Is to go to these notes, and then we go to and get that explanation that is given there. Yes.
So on what he said, or is contradicting. I wanted to answer him and say, or it's not necessarily that it's contradictive. All we are saying is that it's hard to finally achieve it if t is less than 3. Am I right, sir? Not that it's impossible,
Beside
but it's
that,
difficult.
beside that, that's why I gave him an example of a 2 by 2. Can one have a 2 by 2 Latin square design with only A and B? Is it possible to have that layout? Yes. But will you be able to achieve what you are trying to achieve? So one of the conditions that I was saying, one of the conditions for Graeco Latin square design, strictly, you must only apply it provided your T is greater than 3. Remember, now we have 3 blocking factors, isn't it? So your treatment must be more than 3, which means it's 4 plus. Same applies to a 3 by 3 Latin square design. A 3 by 3 Latin square design, you have to check how many blocks are you having. You are blocking by how many factors? You are blocking by 2 factors. So it takes us back to that one, that can you have a 2 by 2 Latin square design? That is the question now that I'm posing to you. Can we have a 2 by 2 Latin square design?
No, 2 by 2. I guess so.
Can we have a structure of a 2 by 2 Latin square design? Can we have a structure? Yes, isn't it? But is it going to help us with anything? Yeah, it is. If it's a 2 by 2, it means it's what? It means it's A, B, B, A. This is a 2 by 2, isn't it? But is it necessary to have a 2 by 2 Latin square design? No. It same applies to Latin square design, because you have 2 blocking factors. It's advisable to have a 3 by 3 plus Latin square design, even though it's a T by T. But the conditions is it's better if you have what? More treatment. Not that because you have 2 blocking factors, you can have again a 2 by 2 Latin square design. It's possible to come up with the layout, but what are you trying to achieve by doing that? So same reason that I'm trying to give here. Maybe the way I explained it yesterday, it was a shortcut of what is on your notes. So now me to go to the notes. So when coming to the test, guys, because we're left with 20 minutes, I will, for the tutorials, I will include a question that need you to perform a Latin square problem, deal with a Latin square, Graeco Latin square problem. It's not going to be difficult. What is going to happen, guys, is this one, or let me just go to the notes. Let's do the one from the notes, because this is the last part that you can be asked to do some calculations. This is very, very important for me to cover it. The last one is just a theory. From there you are done, because I want to make sure that before we close today, you have the scope for Friday test. So allow me to open the Latin square notes. Smanga, I'm not in the office, ne? Sorry, I nearly forgot to. I'm not. I'm working from home. So if people want to, if you want to see me, leaders, just drop me an email. Don't waste your time and try to look for me from the office. Same applies to tomorrow. Even tomorrow, I won't be there. So if you need something, drop me an email. And again, the issue of Windows Journal, I can share this handwritten notes again. This one, the one that I'm using now, I can share them with you, and then so that you can go through them if you don't want to listen to the recording. So, but I was told that you must install Windows Journal. You must install Windows Journal for you to be able to open the notes. Someone did that. The notes now they are opening. So please try to get the Windows Journal. I'm coming now. Let me. Yeah, here's the note. Yeah, the note now. So this pamphlet, guys, if you can check, it summarizes what is happening under chapter 5. So whatever is here, guys, this is the summary. So it means you still have to do what? You still have to go to the study guide.
So we
Yes,
can't see.
Christopher. Yes, I'm projecting now. I'm saying don't only focus on this file. I think I shared this chapter 5 with you. Don't only focus on this file, because this is the summary of the study guide. I can ask you something from the study guide. This is just a summary, so that when you go to the study guide, you'll be able to follow what is happening. So let's go to that Gray-Collatin. I think it's the next section. Yeah, it is my brother Shokani.
Yes, sir.
It's supposed to be T. This is T, sorry. So we're saying Gray-Collatin square designs are used when we have three blocking factors, three blocking variables. I explained that one, isn't it, Shokani? So far, we are used to two blocking factors. Now, what would be the third block? It's indicated that the third block will be represented by what? By the Greek letters. And then, so it means you're going to block by rows, columns, and what. So the treatments, the rule remains the same, that the treatments will appear once and only once in each row and each column. With what? Again, the issue of the Greek letters now. The issue of the Greek letters now comes in. Even the Greek letters should not repeat itself. So there's an example here where there's a mistake, but we'll trace the mistake before we do some calculations. So if you can check, this is a 4x4 Gray-Collatin square design. It's a 4x4. You can see now we have what? Letters and Greek letters. The Greek letters goes with what? Goes with the third block. So it's only will give you better results provided you apply it when you are having more than 3 treatments. So again, the model is given by this. Here is the model. Oh, sorry. You have this note, guys. Now you understand the meaning of this. The issue of notation now. The issue of notation. There is this idea of saying tau always goes with treatments. No. As long as it's a Greek letter and you are able to explain it, it's not a problem. As long as it's a Greek letter and you are able to explain it. So, like now, if you say there's that ki, as long as you are able to say ki, it goes with the treatment, with the rows. J, lambda j, it means it goes with the columns. What is the meaning of the third one there? What is that? Is it delta or what? What is that symbol there?
Delta.
Delta.
Is it delta K? And the one which looks like a W is called what? So what I'm trying to emphasize here, as long as
Omega.
you are able to, it's omega. As long as you are able to explain what your parameters represent, is fine. So you will be guided by what? When I see Ki here, I know this for the rows. When I see J, I know this is for the columns. When I see K, I know this one goes with the treatment. When I see L, I know this goes with what? With the Greek letters. But as I've indicated, as long as you know how to write the model, it's not a must for you to know memorize these Greek letters, these parameters. Just come up with any parameters. There's lambda, there is gamma, there is rho, there are many. Just write Greek letters. As long as you're able to interpret them, it's fine. I thought there's a hand. So even in the afternoon, I will try maybe to come for questioning. I can come for the tutorials for questioning. I will upload the 2 questions for the afternoon tutorials because Mr. Bao will need the first 45 minutes and the other 45 minutes. If there are questions based on my tutorial, you can simply ask me during the second session. I can come just to, not to give you the answers, just to clarify you where you don't understand. I don't have a problem with that one. So your ANOVA table will be like this. The procedure is the same as for the normal Latin square design. We don't have replications here. We don't have replications in this set. So it's like the normal Latin square problem. So here's the question, guys. So this question, I noticed that there's a mistake. If you can check the last column there, there is that, is it a row or what? I think that thing is repeating. If you can check the first column on Friday and the last column on Friday, that thing is repeating there, isn't it? So we have to trace what is not, which one is wrong there. So I think B is supposed to be attached to delta, right? If we put delta there, the last row, the last column and the last row, where there's 176, I think it's supposed to be delta, isn't it? Yeah, it's supposed to be delta. So corrections there. You'll also correct from your notes, ne? Correction. Last column on Friday. The what? The Greek letter is supposed to be delta. It's supposed to be delta there. Delta is the symbol that is attached to D on the first row, on the first column on Tuesday. That is delta. So please change that. Is supposed to be B delta 176. So please, guys, this will be a tutorial question. I will create questions for you that you should answer related to that data set. So I will create questions for you, and then you will do it during the tutorial. And with the remaining 10 minutes, this one now, I won't ask you to do any calculations. The Jordan square design. This one, don't expect any calculations. What you have to know is the definition. How does Greco-Latin square design differ with this one? This one is the easiest. This one, we call it Jordan square design. We call it an incomplete Latin square, where the number of treatments, where the number of rows are not equal to the number of columns. Let me repeat. Jordan square design is an incomplete Latin square design where the number of rows are not equal to the number of columns. So it means this one, in short, is not a T by T design. Your Jordan square design is not a T by T square design because the number of rows are not equal to the number of columns. For example, let's check that given example there. You have 5 rows, you have 4 columns. But the letters, remember, they should not repeat in any row or any column. But it's an incomplete Latin square design. Any question based on this your then square design? Any question based on this your then square design? Based on Graeco Latin square design, even though I'm still going to ask you during the tutorials. Any question that you have now? Yes?
Sir,
Yes.
I need an advice here on this Graeco Latin square design. I mean,
Yes, my brother.
since you said it won't be given less than, or only be given for, and you will obviously have to sum each for the Greek letters. And
I can
and
hear
the
where you're
time,
going,
sir,
Miss
and the
Mang.
time, sir, each time
I can hear
some
what
of
you're
us.
going. But usually, Mrs. Mang, sometimes we will help you. Maybe we can square the values for you. It's something, isn't it, Mrs. Mang? If we square the values for you, I think it means we tried something.
Yeah,
And
that
again,
will be
remember,
better.
I think Mrs. Manga, and you once came to my office and then I said something that there's something that you have to understand, guys. We are not testing if you know how to add or subtract, isn't it, Mrs. Manga? So obvious things will in most cases will give you obvious things like adding the values which goes with Monday. We can add the values for you because we are not testing you if you know how to add values, isn't it, Mrs. Mang? So you should not fail because you fail to add values. So some of the things, Mrs. Manga, to be honest, will meet halfway. But there was a day where I was told that this thing of summarizing data for us, you are confusing us. You remember the comment, Mr. Mang, that if I give you the summary of the data set, some
So I
leaders
think
start
it's
complaining.
much better. Say those who want to calculate, they can verify for themselves because say time, say are not all the same. Like
Oh, you are
numbers.
saying I should give you the data set or and again the summary so that if those who want to use the summary, they can go with the summary. Those who
Yes,
want to use the
that's
data
much
set, they can go
better.
with the data set.
Because these things they are simple, you can see, but time is not on our side.
Yeah, you are right. You are right there. So even on Friday, guys, you should manage your time. Just manage your time. Start with the question that you understand better. Make sure that you score as more marks as possible because we don't know. This might be our last test because looking at the time, guys, we have to write a quiz. When can we write a quiz? And I don't think there will be another quiz after the one that I'm about to propose now. Because I was thinking that why don't we write a quiz next week? But someone told me that computer science students are writing on Friday. We have to, because otherwise, if we go for recess without writing a quiz, it won't be easy for us to write a quiz when we reopen.
Next week, Monday.
Otherwise, it means you
We
write
are
a quiz
writing Monday.
immediately when you come.
Good
Yeah, that's what I'm saying.
afternoon, sir.
Otherwise, you write a quiz. You write a quiz immediately when you come back for recess
Yes, that's what I
on
wanted to
Tuesday
say.
after recess. Is it fine?
Yes.
But it eliminates your request of 4 quizzes.
Sir,
Because when we reopen, we'll be left with only 2 weeks and 2 chapters.
sir,
Yes.
can we have maybe a retest after we open the first? You leave the quiz because it won't boost anything. A test will be much better.
No, I don't want to have, the test, how to mark a test, Mrs. Manga. Because remember, when we reopen, Mrs. Manga, we'll be left with 2 weeks.
Sir, please,
That's what I'm
sir.
saying. That's what I'm saying. The best thing was to write a quiz before. It was to write a quiz before we go for recess. But since others will be writing, we end up maybe disturbing them to prepare for other modules because they'll be writing tests, not quizzes. So discuss with your class reps, guys. When can we write the test? Is it next week or no? The quiz, sorry. Is it next week or the Tuesday when after recess? Because you said you want 4 quizzes. So far we wrote 2. So I don't think we'll be able to get to 4. So far I didn't get the feedback from my boss, but I'm just trying to say maybe let's write another one and then we take the best 2. Also to accommodate those who love submitting via email, even though it's not allowed. So they will be safe there. So when can we write the quiz, guys?
I'll
After,
say we can write it tomorrow since we're writing the same
Hey,
things
hey,
on Friday.
quiz tomorrow, you will die young. Quiz.
Next week, Tuesday.
But that one I think is a short notice. If it's tomorrow, it's a short notice. Or we can
Next
we
week,
write it
Tuesday.
Tuesday? Next week Tuesday?
You said
Yes.
next week.
Yeah, next week Tuesday.
Preparing for test.
Next week Tuesday.
Next week Tuesday.
No,
Yeah,
next week you
Yes.
are
the
writing.
scope on Tuesday.
Next week
Next
Tuesday,
week
perfect.
Tuesday. Yes.
Guys, I said you can the reason why you are not writing on Friday next week is because I heard that there's a test on that Friday. But if on Tuesday you're not writing anything, let's write on Tuesday.
So they are
There's no
writing
test
on
on,
Monday.
so it means Tuesday there's nothing, right?
Yes.
We're writing on Monday,
Because the scope, guys, the scope for the test is the same scope for the quiz. It's not like I won't teach before I give the quiz, isn't it? So if we write on Tuesday, so it means the very same scope that you're going to write test is the very same scope for the quiz. Yes, Manga. Mrs. Manga. Let me stop the recording because it